Today we will try to understand the classification of reactions. Now the chemical reactions which occurs in a chemical reactor can be classified on the basis of different conditions and criteria. The first condition is on the basis of order of reaction. Now on the basis of order of reaction, the reactions are classified as zero order, first order, second order, and third order. So, if I consider the rate expression, general form of the rate expression as minus RA is equal to KCA raised to N. So, for N is equal to 0, minus RA will be equal to K. It means zero order reactions depends on parameter other than concentration. It may be dependent on surface area of catalyst, intensity of light, etc., etc. For the sake of your understanding, the reaction between hydrogen gas with chlorine gas occurs in presence of light. So this does not depend upon the concentration of this reactant. So obviously whenever we are carrying out any reaction, we will always provide the reactant, but unless and until this light energy is made available, you cannot carry out this reaction. There is another zero order reaction which I may write as twice N2O gas, that is dinitrogen oxide decomposition, it depends upon the pressure. It is carried out at high pressure, so it depends upon the catalyst or the catalyst use or the surface area of the catalyst available and independent of the concentration. So such reactions which are independent of the concentrations are known as zero order reaction. Now example of second order reaction. twice NO2 gas gives you twice NO gas plus O2. So basically it's a decomposition reaction. Similarly, NaOH plus CH3COO C2H5, that is ethyl acetate, aqueous, gives you CH sodium acetate plus C2H5OH. So likewise, on the basis of order of reaction, the reactions are classified as 0 order, first order, second order, third order. The second criteria for classification is classification of reaction on the basis of molecularity. So on the basis of molecularity, reactions are classified as unimolecular. The example is N2O4 decomposed to give you twice NO2. Then bimolecular, twice NOCl decomposed to give you twice NO gas plus Cl2 gas. Termolecular, 2 moles of nitric oxide gas react with 1 mole of oxygen to give you 2 moles of nitrogen dioxide. So basically what is molecularity, that I have already explained. So it is basically the number of atoms, molecules or ions which participate in a reactions. So here only one molecule participates, here 2 molecules participate, here 2 plus 1, 3 molecular species participate. That's why it is a termolecular. So far we have seen the classification on the basis of order of reaction, classification on the basis of molecularity of the reaction. Now third criteria for classification is classification on the basis of phases involved. Now on the basis of phases involved, the reactions are classified in 2 types. Homogeneous heterogeneous. Now what is the meaning of homogeneous and heterogeneous? So in homogeneous reactions, reactant, product, if catalyst is catalyst, if all are in same phase, the reaction is known as homogeneous reaction. Now, if reactant or product or catalyst or all are in different phase, then the reaction is known as heterogeneous reaction. If all reactant, product, catalyst, everything, every component including reactant, product and catalyst, if all are in the same phase, then the reaction is known as homogeneous. If either reactant or product or catalyst or all are in a different phase, then the reactions are known as heterogeneous reaction. Now the example of homogeneous reactions are the reaction of hydrogen gas with fluorine gas to give hydrogen fluoride gas. The another example which we just saw before some time was the reaction between ethyl acetate with aqueous NaOH solution. It gives you CH3COONa plus C2H5OH. So everything is in the same phase. So these are the examples of these two reactions are examples of homogeneous reaction. There are other reactions, there are other examples also. Say for example, the reaction between hydrogen plus bromine, both are present in a gas phase and they form hydrogen bromide gas. All are in a same phase. So this is an example of homogeneous reaction, right? Now heterogeneous reaction. The example of heterogeneous reaction, suppose nickel oxide, this is solid. Now if this is reduced with the help of hydrogen, then what we will get is nickel metal plus water vapor. So see, these reactants are in a different phase, products are also in a different phase. So this is one example of heterogeneous reaction. The another example is you have seen in a manufacturing of sulfuric acid, where first is to convert sulfur dioxide into sulfur trioxide. So the reaction between sulfur dioxide with oxygen, that is oxidation, partial oxidation of SO2 in presence of V2O5 vanadium pentoxide catalyst to give you 2 moles or 2 molecules of sulfur trioxide. So here sulfur dioxide is gas, oxygen is gas, sulfur dioxide is gas, oxygen is gas, sulfur trioxide is also gas, but since the catalyst is in a different phase, vanadium pentoxide, it's a solid, and therefore it is an example of heterogeneous reaction. Likewise, you must have seen ammonia manufacturing, ammonia synthesis. It is an example of heterogeneous reaction. The another example of heterogeneous reaction is calcination reaction, where the solid is decomposed by in presence of heat and in absence of oxygen. The thermal decomposition of any material in absence of this oxygen can be considered as a calcination, and that calcination gives two products. One is gaseous product and another is the solid product. So that calcination is also an example of heterogeneous reaction. And now the trend is to so even if we are earlier we might have experimented the liquid catalyst and two liquid reactants in presence of certain liquid catalyst, acid base catalyst giving liquid product. That was earlier trend, but again the workup after reaction is over, that is product separation, then pH adjustment, etc., becomes difficult. Therefore nowadays the trend is to go for the heterogeneous reaction. The another popular example of the heterogeneous reaction is hydrogenation of vegetable oil, where the hydrogen is bubbled through a vegetable oil in presence of Raney nickel catalyst in order to obtain vanaspati ghee. So in this way, when all reactant products and catalyst are in a same phase, the reaction is known as homogeneous. If either of them is in a different phase, then or all are in a different phase, then the reaction is known as heterogeneous reaction. Now, fourth way of classifying the reaction is elementary reactions and non-elementary reactions. Now what does it means by elementary reactions and non-elementary reactions? Now just consider the general form. Say for example, or first of all let us try to understand their definitions and then we will see the examples. So elementary reactions are the one in which rate expression corresponds to stoichiometric equation. Now, what does it mean? For example, just to understand the meaning of this statement, let us consider the reaction is 2A gives you P. So, if the rate expression is written as KCA square. Now, from this stoichiometric reaction, the number of atoms or molecules which participate in a reaction are 2, so molecularity is equal to 2. Power which is raised to the concentration terms in a rate law expression is known as order of reaction. So, order of reaction is 2. So, when order is equal to molecularity, we say that the rate expression corresponds to stoichiometric equation. Take another example. 2 moles of A reacts with 1 mole of B to gives you certain product P. Now here 2 molecules of A are reacting with 1 molecule of A, or say 1 atomic, means there are, so the simplest way of calculating the molecularity is to take the sum of stoichiometric coefficient. Now here stoichiometric coefficient of A is 2, stoichiometric coefficient of another reactant is 1. So from this reaction, for above reaction, molecularity is equal to 3, 2 plus 1, or there are 2 atoms of A reacting with 1 of B, so 2 plus 1 is equal to 3, or sum of the stoichiometric coefficient 2 plus 1 is equal to 3. So let us understand, if rate expression is minus RA is equal to K Ca square Cb raised to 1. So if it is raised to 1, then we don't write. Now what is order of reaction? Order of reaction is equal to sum of individual order. Order of reaction is known as sum of the power sum of the power which are raised to the concentration terms in a rate law expression, right? So the powers are, the 2 is pronounced as individual order of reaction with respect to A. So the order of reaction with respect to A is 2, order of reaction with respect to B is 1, and overall order of reaction, which is basically known as order of reaction, is equal to 3. So molecularity of reaction is equal to 3, order of reaction is equal to 3, and therefore the reaction in which order of reaction and molecularity of reaction are same, or the reaction where the rate expression corresponds to stoichiometric equation, is known as elementary reaction. Now we will see some examples of order of reaction, elementary reaction and non-elementary reaction. Now let us consider the reaction N2O4, which decompose to give you twice NO2 plus plus n. Now in this case, the rate expression is like this. Therefore, n is equal to 1 from the equation, stoichiometric equation. Molecularity is equal to 1, and since order is equal to molecularity, it is an example of elementary reaction. Another example of elementary reaction is C2H5OH plus CH3COOH gives CH3COO C2H5 plus H2O. Now in this case, the rate expression can be written as K concentration of C2H5OH into concentration of CH3COOH. Now the power raised to this concentration of ethanol is 1. Power raised to the concentration of acetic acid is 1, and therefore order of reaction is equal to n is equal to 1 plus 1 is equal to 2. Now again, from the stoichiometric equation, molecularity is equal to 1 plus 1, 2. So order of reaction is equal to molecularity, and therefore this is an example of elementary reaction. Please remember, the best part about the elementary reaction is once it is stated in the problem or in the statement that it is the elementary reaction, you can directly write the rate expression. Now I could write the rate expression directly because it was known to me, or it was said that it is an elementary reaction. If somebody just write the chemical reaction and he asks you to write the rate expression from the by referring to the reaction written, you should never write it like this. You should first ask him whether the reaction is elementary or non-elementary. Now if he says the reaction is elementary, then you can directly write the rate expression. Say for example, now say the reaction is 3A gives P. If I told you that the reaction is elementary, then the rate expression will be equal to K Ca raised to 3. Molecularity 3, order of reaction is equal to 3. So this I say that it corresponds to stoichiometry. Or say the reaction is elementary and the reaction given is A gives P, and if I ask you to write down the rate expression, so your first question is whether the reaction is elementary or non-elementary. If I say that the reaction is elementary, then you can write minus Ra is equal to Kca. Now molecularity 1, order of reaction is equal to 1. So order is equal to molecularity, and therefore this is an example of or the elementary reactions. There is another characteristic of the elementary reaction. Generally, the elementary reactions has to overcome only one energy hump, that is basically elementary reactions are the single step and simple reactions, or whenever one reactant is giving one product in a single step, then probably the reactions would be elementary reaction. But if there are the series of reactions involved, then you are aware that for every reaction there is certain minimum amount of the energy required. So in that case, more than one energy barriers are to be overcome. So whenever only one energy barrier is to be overcome, the reaction is known as elementary reactions. So if I have to explain this, then I can say that suppose if the reaction is elementary, it may be anything, say 3A gives P. Now one energy barrier is to be overcome means what? Say this is the initial state of the reactant. So this represent energy level or energy possessed by the molecules, and this is distance along reaction path. So when the reaction will be started, depending upon whether it is exothermic or endothermic reaction, say you have started with reactant A and now you are ending with reactant P. So there is only one A, and this particular energy represent the activation energy, the minimum amount of the energy which is to be supplied in order to initiate the reaction. The amount of the energy required for making or breaking of the bond is known as activation energy. So unless and until this much energy is supplied, the reaction will not proceed. So when only one energy barrier is to be overcome, whenever there is a single step, single reaction, then such reaction is also known as elementary reaction. Or another definition, the reaction in which the rate expression corresponds to stoichiometry is elementary reaction. Third definition, the reaction in which for order of reaction is equal to molecularity is known as elementary reaction. As discussed earlier, now what do you mean by non-elementary reactions? Now non-elementary reaction, as discussed earlier, are the reactions where the rate expression does not correspond to stoichiometry. What does it mean? Say, consider the simple example, acetaldehyde, it decomposed to give you CH4 plus Cu. Now if this reaction would have been elementary, then the rate expression would have been of the form minus rate of disappearance of this is equal to K concentration of CH3CHO. So molecularity is equal to 1, order of reaction is equal to 1 if this would have been non-elementary reaction. However, it is non-elementary reaction. However, it is non-elementary reaction. Please remember, it is not elementary, it is non-elementary. How you can recognize it? If you observe its rate expression CH3CHO, it is of the form in place of 1, here the power is 1.5. Now you may say, sir, how can you say that it is 1.5? Please remember, molecularity is a theoretical term. Just by observing the stoichiometric equation, you can say what might be the molecularity. Now, if you observe this, the molecularity of this reaction is 1. But if I say that, what is the order of reaction? Your first question to me, counter question to me should be, sir, whether the reaction is elementary. If I say yes, then you will say that if it is elementary, then order of reaction is equal to molecularity, so order will be 1. But if I say it is non-elementary, now write the rate expression, then your answer should be, sir, we cannot write, because for non-elementary reaction, in order to obtain the rate expression, we must have the data fitting using the experimental data, and so the form of the rate expression can be calculated by performing the experiment and fitting the experimental data in the general form of the rate expression, that is minus RA is equal to Kc raised to n type of the equations. If you add that data, if you simplify it, and by either numerical or graphical means, you will be able to calculate the value of order of reaction and value of rate constant. And if value of order and rate constant and the format of equation is known, then you say that we know the complete rate expression. Now here K is not known, so we cannot say that it is the complete rate expression. However, at least the format of the rate expression is sufficient to tell us that the molecularity is 1, order of reaction is 1.5, so order is not equal to molecularity, and that is why the reaction is non-elementary. So there is another reaction, carbon monoxide reacts with chlorine to give you COCl2, and the format of the rate expression is minus disappearance of carbon, rate of disappearance of carbon monoxide is equal to concentration of say CO into concentration of Cl2 raised to 1.5. So here, if this would have been the elementary reaction, the molecularity is 1 plus 1 2, so the order should have been also 2, because order is equal to molecularity in case of elementary reaction. However, if you observe the rate expression, then just by observing the rate expression you can say that, sir, this is non-elementary reaction, because order of reaction is equal to order with respect to CO1, order with respect to Cl2 1.5, so 1 plus 1.5 is equal to 2.5, so order of reaction is 2.5, molecularity of reaction is 2, so order of reaction is not equal to molecularity, and that is why it is an example of non-elementary reaction. Now, on the basis of the next criteria of classifying the reaction is on the basis of heat effect involved. Reactions may be exothermic or endothermic. So the reaction may be on the basis of heat effects involved. The reaction may be exothermic or the reaction may be endothermic. Now exothermic, you are aware that in exothermic reaction the heat is evolved during reaction. So explosion, combustion, all these examples are the example of exothermic reaction. For example, the reaction which involves the oxidation, that is combustion of methanol, the product of complete combustions are always carbon dioxide and water, and the heat evolved is equal to minus 890 kilojoule. There is another example, H2 gas plus F2 gas twice HF here 130 kilocalorie. This is I think 890.4 kilojoule. Delta H is equal to 130 calorie. There is another example, or you will get so many examples related to endothermic and exothermic reactions. Now the last, in endothermic reaction the heat is absorbed. So the examples of endothermic reactions are calcination, where heat is supplied, we get calcium oxide salt, that is lime, and the heat to be supplied is 177.8 kilojoule. So heat evolved is negative, taken as negative, heat absorbed is considered as positive. There is another example, the reaction between nitrogen and oxygen gives you nitric oxide gas, and the heat to be supplied is 45 kilocalorie. So in this way, the reactions in which heat is absorbed are known as endothermic. The reactions in which heat is evolved are known as exothermic reaction. And that is why while studying manufacturing process, you must have studied that since heat is evolved, it is to be removed by applying the cooling, whereas since heat is absorbed, Therefore, these reactions are favored by supplying the heat. So these type of the reactions require heat, supply of the heat, whereas this type of the reaction requires removal of heat. So in this way, we have tried to understand the classification of the reactions on the basis of order, on the basis of molecularity, on the basis of phases involved, on the basis of phases involved, on the basis of elementary and non-elementary reactions, nature of the reactions, on the basis of different phases involved. I hope you must have understood whatever we have discussed in today's session. So thank you for watching this video, and I will keep on posting the similar videos on my YouTube channel. Do visit, you may share among your network, and if you have any questions or query, you can comment related to videos in a comment box. Thank you once again.